Okay, so to sort of see all these functions which maybe are sort of swimming around your head, let's play match game. That's right, match game, where I give you the equation of a whole bunch of functions and then show you a picture one at a time, and we have to figure out which things match with which. Okay, so here's a chance for you to be interactive. Here we go. So here are the functions. Y equals minus 2 tan x. Y equals secant 2x. Y equals cotangent x. And finally, last but not least, y equals minus cosecant x. All right, well, I'm going to give you the graph, and then you see if you can figure out which of these things actually it relates to. So here's the first one. So your mission is to see which of these might this be the graph of. All right, give it a try right now and enter in your guess, and I'll come back and we'll see if we can do it together. Okay, well, here's exactly how I think about it. To be honest with you, I'll just let you know how I think about it. Wherever I see an asymptote, I know this thing is going to cross the x-axis if I think of its reciprocal. I'm going to try to untangle this by thinking of what reciprocal thing this function is. So wherever I have an asymptote, I know I'm going to cross the x-axis. And then I see this is going to be a low point, and then from here I must be sort of going, if this goes up, this will come down. So it's going to sort of go down and then up and then down and then down and then up and then down. Now what does that look like? Well, that has sort of a cosine-ish feel to me. It's sort of a cosine-y kind of thing. So therefore, the flip of that must be a secant-y kind of thing. Yep, and I see a secant thing right there. It's the only one. So this must correspond to secant 2x. So there was a period thing there, which I just missed because there's no markings here, really. So therefore, this must be secant 2x, or at least a close facsimile, because it's just the reciprocal of cosine. Okay? Okay, now I want you to try this one and see if you can guess this one. So here's the graph. Here are your choices. Good luck. Well, again, I'm going to try to look at the sort of the reciprocal thing of this. So wherever I have an asymptote, I know our function is going to actually go through 0. Wherever I have 0, I know I'm going to have an asymptote. See, when you take an inverse, 0 is an asymptote switch. And what happens here? Here, as this gets smaller and smaller and smaller, the reciprocal will get larger and larger and larger. And similarly here and here. And that blue looks to me like what? Well, it looks like a tangent to me. That looks very much tangent-like. So in fact, the red, the original thing, must have been the reciprocal of that, which is cotangent. So I guess that the red actually is the graph of cotangent x. You see how I'm playing this game? I'm just looking at the reciprocals, seeing if I can make a good guess as to what these look like. Here, how about trying this one? Now it's 50-50 shot, I guess. Try this and see if you can try to figure out what the graph of the reciprocal of this would look like and see if you can recognize it. Give it a shot right now. Well, let's see. Wherever I have an asymptote, I know the reciprocal will be 0. And so what do I see? I see this, and I see a 0 here and a 0 here. Here, this thing is getting larger and larger and larger, so therefore this must be getting smaller and smaller and smaller, so I must be going sort of up, down, like this. So that doesn't exactly look like sine, because remember, of course, sine looks like this. And this is the reverse of it. This comes down over here instead of going up. So it must be negative sine. So this must be the graph of negative sine, which means that reciprocal would be minus cosecant. Well, there's minus cosecant. So even that minus sign I was able to detect by seeing that the reciprocal is actually negative of the sine. So this must be negative of the reciprocal of sine, which is negative cosecant. Okay, the last one, in fact, I'll do, since there's not too many guesses here. This should be negative 2 tangent x. No reciprocals here, but just think of the tangent function, and what happens if I multiply it through by a negative? Well, what happens if I multiply it through by a negative is that the roles of positive and negative switch. So if I just do a reflection, you see good old-fashioned tangent. But if I take every positive value and make it negative, and every negative value and make it positive, it reflects and I get the red. So in fact, this really is negative 2 tangent x. The 2 part's hard for me to tell because the axes aren't labeled, but in fact, this is the right shape for minus 2 tangent x. Anyway, I hope this gives you a sense of how the coefficients sort of affect what the picture looks like, and these reciprocal functions aren't that big of a deal as long as you remember what's a 0 for one function will be an asymptote for its reciprocal, and what's an asymptote for one function will be a 0 of its reciprocal. Armed with those things, you should be home free. Good luck, and congratulations if you won some wonderful prizes here on Match Game. See you soon.